In this lesson, we're going to actually start looking at the language itself. We're going to go over some explanations of some rules and what we'll call the syntax later on. If you're just starting with this PowerPoint format video, then what you need to know is when I stop talking, that means that slide's over, and you'll need to click on your screen to go to the next slide. All right, JavaScript is known to belong to one of the programming languages known as object-oriented programming. And we're not going to go into a full-blown description of what object-oriented programming is, but you do need to know some of the terminology and the way the program is built. And the three main things we're going to cover are the objects, the methods, and the properties. Objects are most of the time, and for our purposes, built-in things that the program language understands. So we might have a document, we might have a form. So the nouns of our programming language or the programming sentence that we're going to write means the object is something that is either going to do something or have something done to it programmatically. When we're working with objects, the word object actually describes the built-in template that is part of the programming language. When we use those objects, we use instances of those objects. And I'll have an example of this in a minute that'll maybe make it a little bit more clear. Now the methods are also built into the programming language, and they're generally associated with objects. Methods are the verbs or the actions that can take place, and certain objects will have certain verbs associated with them that make sense. So the methods aren't just interchangeable, they're pre-built into the programming language to where certain objects can do certain things. Now properties are the same way. A lot of times they're tied to the objects themselves, and properties describe the object. They're the adjectives or the descriptors of the object. And so those are the basic building blocks of our programming language. If you were to get into a more advanced programming language, you can actually create your own objects and create your own methods and properties. But for the ease of this class and for what most people do in JavaScript, the objects and the methods and properties that are built into the language generally serve your purposes. So here's the classic example used a lot of times to explain to people what object-oriented programming is or what objects are and how they interact. And so what we're going to do is we're going to talk about a car. Everybody knows a car. When I said the word car, you probably pictured something in your head. Most likely it was your car. But we all kind of agree that a car is something that drives on the road. It could look different. It could be a truck, or it could be it could potentially be a motorcycle or something like that, but most of us probably picture a sedan or something like that. So car in our example here is a predefined object. Now if we want to work with a specific car, then we would make an instance of the car. So in my case, well, let's talk about my car. I'll come back and talk to you about why it's smushed together and capitalized like it is. But my car is going to be the instance of the car object. And so because my car, the instance that we're using, is based on the template of this idea of a car, we could probably say that my car has four wheels, it probably has a steering wheel, it has some seats, a trunk, a hood, things like that. So the car idea is predefined, and when I buy one and I have my car, then it inherits those things associated with the concept of a car. Now the car has methods that are predefined. Cars can go, they can stop, they can turn. And remember, the methods are specific to the object. It wouldn't make sense to have eat or jump or fly, something like that. That doesn't really make sense because that's not what cars do. Now we also describe my car. It's going to have properties. It can have the model, it can have the year, it can have the color, we can have type. So if we wanted to say truck versus SUV versus sedan, we could have other things like economy, miles per gallon, all kinds of things that we can use to describe a car would be the properties of the car. Now let's take that one step further and talk about those instances, methods, and properties as we would if this were really the programming language. Now remember, this is just an example, but it will give you an idea of how it's going to work within the programming language. And the programming language itself is going to use something called dot notation, and it allows you to reference those properties and methods in particular. And so just let's look at some of these examples. If we were talking about my car going, we would issue the command to make the car go because that's a verb. Remember, methods are the verbs. So in this case, we have my car dot go. Methods are always going to have those parentheses, and if the method needs more information about how to do its verb or its action, we would fill that in there, and I'll show you in the next example. My car dot turn, another method, but the car might need more information. Is it going to turn left or is it going to turn right? If we put something inside the parentheses, then those are going to be called parameters. And so my car dot turn is the method, the instance and the method, and left is a parameter or additional information that it needs for it to complete the action. Now the next three examples are examples of the properties. Notice that the properties are equal to something. So my car dot color, talking about the color of my car, means it's going to be equal to red. My car dot model can be equal to Honda CRV. Now look at the last one. I just noticed I have a typo. It's not mu car, it's supposed to be my car. But if I had my car dot mileage equals 137,000, notice how it's different from the previous two, and I'll talk about this later. But when we're storing words, notice we put double quotes around them. In this case, my car dot mileage is equal to 137,000. That's a number that has a value to it, and so we actually don't put it in quotes because we might want to do math with it later or comparisons or something like that. But these are just some examples of how a programming language might look. In the real world, we're going to see in the next slide how it actually works with our document that we're going to use in the browser. So hopefully you get the general idea of how the dot notation works, because what we're going to really use that with are the things that we are going to use in our HTML documents. So we need to talk about the DOM, or the document object model. And what this does is it outlines some of the properties and some of the objects that we use frequently and how they actually can be nested. So for example, you could change something about the window, but the window also in the browser will contain a document. On that document we might have a form, and we might want to change something about that form. Or the form itself is going to have form fields like drop-down menus and text boxes and things like that. We might want to read values off of that form, or we might want to change the values on that form. And so we have to understand how the document interacts throughout the whole object model. So for example, if I wanted to change the background color of the document to red, I would write the statement window.document.bg color equals red. And what that does is I'm telling the browser to go to the window. Inside that window you're going to find the document, the current document that's loaded, and I want you to change a property of the document, in this case BG color, and set it equal to a value of red. This is a long-winded way of changing the background color. We've already done it with HTML and CSS. This is just another way to do it. And you might say, well, why would you want to do that? Why not just do it with CSS? Well, you might have buttons on your page that let your visitor choose what color the background. So if they click the yellow button, then you will issue the command window.document.bg color equals yellow or green or something like that. One thing to know as we go through this is in this document object model, the window object is understood. So a lot of times you won't see people write it. You'll see people start with document. So realistically in the example above, you wouldn't very often see window.document.bg color equals red. Most of the time what you would just see is document.bg color equals red. So here are actually some real examples of JavaScript that you could write into your code right now if you wanted to. Let's talk in detail about some of these things. So the first example says document.write, whereas document is the instance of the object. .write is one of those built-in methods. And then in parentheses, we're going to give it more information about how to do that. In this case, we're going to tell it what we want to write. So we put the words hello there in quotes. And what this example does is it tells the browser to go to the document and write hello there to the document. So this is just another way to put text into the browser. Now a lot of times you'll retrieve text and change text programmatically. Very rarely will you write just a statement. So the second example is saying go to the document, find an image named image1, and set the source to cute kitty. Now you're also going, well, why would you want to do this? Come on now, let's just use HTML to write the image source and have it be done. Well, you again remember we're talking about interactivity. We might say, and I'll tell you how to do this later, we might say, hey, if the user puts their cursor on top of an image, which is not cute kitty, when they put their cursor over it, I want you to dynamically change the image that's there using the source property and change it to cute kitty. So you have a rollover effect when you put your mouse over it, changing the source of the document. Now the last one's a little bit harder to explain, so let me start on the inside and work my way out. Document.lastModified is a property, and I'm going to show you the properties of the document in the next slide. But what it is it is a property that every time you save your HTML document, it kind of timestamps when it was saved. So you get a date and time when the page was last saved. And it's stored in a property of the document. So what we're doing here is we're retrieving the information stored in that property, and we're going to have our write method write that information to the screen. So what we do is we use the document.write method, and the additional information that we're giving it to write is telling it to go retrieve what was stored in last modified property and fill it in here. Notice the difference between the first and last example. The first example has double quotes around it, and that means it's literally going to write whatever is between the double quotes. The last one doesn't have double quotes because it actually wants the program to go do something and fill in the blank, if you will. And so if we had put double quotes around document.lastModified in that last example, it would have literally put document.lastModified. It would not have retrieved the date information that we were after when the document was actually last saved. Alright, so let's look at some of the more common properties of the document. BG color, FG color, BG stands for background and FG stands for foreground. Your link, either your regular link, your active link, or your visited link, those are the next ones in the list. These all allow you to change color properties of things on the page. And again, we've done this with CSS 100 times, so you might say, well, why do these things even exist? Like I said, you might have reasons for changing it or allowing your users to change it dynamically. Now the location property of the document is actually the URL of the existing document, and you're sitting there going, what the heck, why would you ever need to tell them where they are? It says in the browser where they are. Why would you document.write location? That's not the most common use of it. The most common use is to change that programmatically. If I issue the statement document.location equals http://www.yahoo.com, when that line of code executes, it'll actually change them to that location. It'll actually change the current location of the document from whatever the URL is to what you want it to be. Refer tells where the person came from. It's not used very often. A lot of times it's used to collect statistics. Title is what appears on the title of the page, just kind of like our title property or our title tag that we're used to setting in the head section of the document. We can change that programmatically. And as I talked about briefly in the last slide, last modified is that timestamp of when the page was last updated. And so if you want to show people that your pages are up to date and that you've been working on them or that the information on them is current, instead of having to go in there every time you write your code and say, oops, I'm going to go down to the bottom and say today was the last day it was modified, you can put this JavaScript in, and every time you save the page, it'll automatically update that information for you. And we have to learn the rules. Like a programming language like English or Spanish, when you learn to put periods and commas in and set up adjectives and things like that, programming languages also have grammatical rules, and they're going to be known as the word syntax. So some of the things that you need to know when you're writing your code, and this will drive you crazy, the first one is capitalization counts. Up to this point, when we've been writing our HTML and our CSS, we could use capital letters here, capital letters there, didn't matter. Capital P tag, lowercase p tag, the browser knew what you were talking about. It wanted a paragraph. JavaScript's not the same. You will probably find yourself messing this up a little bit as you get going, but capitalization does count. So in the example on the slide, notice that document.write with a capital D in document is not the correct way to write that statement. It should be document.write hello with a lowercase d. If you were to write the first statement, you're probably going to get an error telling you that it doesn't understand what you're saying because document with a capital D hasn't been defined anywhere. So to save yourself some heartache, what you might want to think about is using what's called camel case numbering. And the methods and properties in JavaScript use this. And so that's why a lot of times when you're naming things or when you're trying to type stuff out, you should probably be aware of this. And what it is it's just a way of making capitalization consistent. And so if you have a property, or later on we'll talk about variables, or you're going to set up an instance of something and you're going to name it, if it has multiple words in it, in other words, my car, the way you would do it is you would have the first word begin with a lowercase letter, and then every other word that's smushed together would begin with an uppercase letter. So in the examples you see a lowercase m and a capital C for my car. Same with model year, and then of course this is an example, has multiple capital letters as new words are added. Next rule. Almost all statements will end with a semicolon. This is the same thing as a period in an English sentence. It indicates to the browser, in this case, that that's the last of that sentence, that it's going to end that executable statement, and it needs to go on to the next one. Now, as we get a little bit further into the programming language over the next week or so, there will be some statements that do not end with a semicolon, and I'll try to point those out as we come to them. Alright, so methods, they'll always have the parentheses like I mentioned previously. They might or might not have parameters in them, but the method itself will always have the parentheses. So if you did document.write, there should be parentheses there. If you leave it blank, it won't write anything. If you fill it in, it'll write whatever's in the parentheses. So using properties. When you're working with properties and changing properties through your programming, you're going to use the equal sign to assign values to properties. So if we have that document.bg color equals red, and then somebody clicks a button, then we would have a new statement that says document.bg color equals yellow, because properties are going to be equal to something. Now, if you retrieve them like we did in the last modified example, That's different. You're not setting a value to those, you're just retrieving what's currently stored in there. But if you are changing the property, which you do a lot in programming, you need to be sure and use that equal sign. Okay, last set of rules for now anyway. We're going to talk about the use of double quotes. And I talked about it in an early example, but when you literally want the browser to print something using document.write, you're going to enclose that in double quotes. In the example there is document.write double quote hello means that it would actually write the word hello would show up in the browser. If you didn't put the quotes on there, what the program would think is that it was another part of the program, something that you were storing something in, or maybe another part of the predefined classes and things like that. And because it doesn't recognize it, what it's going to do is it's going to give you an error. Now let's talk just for 1 second about one other thing and how to deal with numbers. If you document.write, or if you later on are setting properties equal to something, should you put quotes around a number or should you not put quotes around the number? And it really just depends on what the number is going to do. If you are ever going to do math with the number, then you want to feed that into the program without quotes. You want it to actually feed in as a numeric value so you can then do math with it. There are some examples when you use data that looks like numbers, but it really doesn't have any numeric value to it, where you would actually want to feed that into the computer using literal. You would put it in double quotes. And an example of that is the Social Security number. Social Security number looks like a number to us, but it really doesn't have numeric value. In other words, I would never add my Social Security number to your Social Security number to get another answer. That's just nonsense. So things that look like numbers, like zip code and Social Security, student ID, things like that, they look like numbers, but they're really never going to act as numbers. And so if you're doing that, you probably want to go ahead and enter them with double quotes around it so they have a literal value. Okay, one of the last things we're going to do is we're going to talk about concatenation. And concatenation is just a fancy word for stringing stuff together or smushing stuff together. And what will happen a lot of times is your program will go out and run. It might calculate a value. It might retrieve something that's stored in a property, might retrieve something stored excuse me, in a variable, which we'll talk about later on. And you don't literally want to write the name of the property. What you want to do is have your literal statement and then have the computer tack on to the end of the sentence or into the middle of the sentence whatever it is you have calculated or retrieved. So an example right here on how to concatenate is our document.write statement. And the way this is going to work is we're going to tell the browser document.write, and literally we want it to display the words "this document was last modified on." And then what we want it to do is go retrieve the value stored in the document.lastModified property. So what we'll do to concatenate it is we'll use the plus sign, and that will add onto the end of that sentence. And notice the document.lastModified is not in double quotes, and so it means that it needs to go retrieve or execute that. It goes and retrieves the last time the page was saved, and it adds it to the end of that statement to where it would say this document was last modified on July 14, 2014 at 3:33 p.m. And so literally double quote says that we put this document was last modified. We concatenate using the plus sign and allow it to retrieve that data or to calculate any data, and then put it on the end of the document. And you can string these together. We could have put a plus sign and then in double quotes put a period, and that would have put a period literally on the end of the sentence. And finally, I want to talk to you a little bit about errors. Unless you're just the most gifted programmer and typist in the world, because typos can cause you some problems, you're going to come across various types of errors with your programming. When we get into the browser, I'll show you some tools you can use to help you find those errors. But I want to talk to you a little bit about what types of errors you might encounter, so when your browser does give you an error, you have a better understanding of what's going on. So the first kind of error is a syntax error. It means you've made a grammatical error. You've forgotten a semicolon somewhere, you've capitalized things wrong. In other words, you've broken the rules of the programming language when it comes to the syntax. So a lot of times the browser will give you a good indication of where the error is, and it'll tell you kind of a good idea, not always a good idea, of why it is an error. A lot of times these things are typos. Like I said, if you capitalize D in document or the W in write or something like that, or if you forget to close your double quotes or forget a parenthesis, something like that, those are the things that are going to bring your program to a grinding halt. It won't give you output, and you have to go in and fix the syntax error before it will operate correctly. So that's the most common type, and like I said, a lot of times it's just you're typing or you're not paying attention to details. The second time is probably the second error. The runtime or compile errors are not very common, particularly in the things that we'll be doing in this class. And what happens is you have the syntax right, but you've asked the computer to do something that is impossible to do. And the most common example of this is you're asking the computer to divide by 0, which is mathematically impossible. So what happens then is, again, your program comes to a grinding halt. It says, I can't do what you've asked me to do, and you have to go in and make some changes to get the output that you've expected. Like I said, those are very, very rare, and the browser is pretty good at pointing out why it's so cranky about what you've asked it to do. Now the third type of error is the worst kind of error, because your program runs, you don't get any syntax errors, you don't get any compile errors, and you actually get output, but your output is wrong. These a lot of times are the hardest ones to find, and they're the hardest ones to fix. Sometimes you don't even realize you have one. You know, if you're doing a calculation, let's say you make a mortgage calculator and you put in the wrong interest rate, you're going to get output, but you're going to get the wrong information on what payments are going to be. And like I said, until somebody points it out, you might not notice it. Another example, let's say you have 3 buttons where you tell the person to pick their favorite color. One's red, one's green, one's blue, and the program is going to change the background color. A logic error would be when they click the red button, it changes the background to yellow. That's not the intended output of the program. And so a lot of times what you have to do is you have to go back in and read your code line by line, try to figure out what it's supposed to do, when it's supposed to do it, and where you went wrong. So that wraps this one up. We'll go ahead and start writing some simple programs in the next lesson, and we're going to use Dreamweaver to do it. So there's going to be a little intro to Dreamweaver, and then we'll get going.